I mean, usually, my take on it is you should just set it straight up to trunk, because then you're gonna know every time that it's a trunk. And even possibly dynamic desirable, if you set both sides to dynamic desirable, you're gonna get a trunk. I wouldn't ever use this dynamic auto, and really, in my opinion, for this kind of thing, you should just go ahead and statically set everything. I don't really, me personally, I don't see the draw of having a dynamic trunking protocol. Like, if you're setting up a network correctly, you know this side's needs to be a trunk, and you know the other side needs to be a trunk, you might as well just statically set it that way. And then verifying trunks. If you do not see, and I touched on this before when we talked about show VLAN, if you don't see a port listed under any VLAN when using the show VLAN command, it's because that port is a trunk. You can also use the show interface trunk command to verify status. So if you do a show VLAN, you're not seeing a particular port, do the show interface trunk command, and you'll be able to see, oh, okay, well, I've got, fast Ethernet 0/24 is set to a trunk, so that's why I'm not seeing it in the VLAN, et cetera, et cetera. And then VLAN Trunking Protocol. So to kind of explain VLAN Trunking Protocol, if you configured 50 VLANs on a switch and you have 5 other switches, that's going to require 250 additional configurations, because you're going to have to configure those 50 VLANs on all 5 of those other switches. The Cisco proprietary VLAN Trunking Protocol, VTP, helps minimize configuration by replacing VLANs across trunks to other switches. VTP sets a configured switch with a special role to propagate VLAN changes to other switches. Now, the first thing I don't like about this is, well, one, again, it's Cisco proprietary, so I usually have an avoidance to anything that's proprietary, because you've usually got multiple pieces of equipment in your network. The other thing I don't like about it is the name. VLAN Trunking Protocol, to me, it almost seems like DTP, like it's a protocol to establish trunking, but that's not what it is at all. It's more of a VLAN replication protocol, where it replicates VLANs that you configure on one switch to all of your other switches on the network. So whenever you think VTP, think of replication rather than trunking. Trunking is, those changes are being sent across a trunk to the other switches, but it really doesn't have a whole lot to do with trunking, all in all. So, I'm sorry.
Would the setting all the other switches to dynamic auto work, or if you configured that one for 50 VLANs or whatever?
Well, dynamic auto.
Because you're configuring one switch.
So these are that's the thing. Like, VTP and DTP are two completely separate animals, and that's why I don't like the name of this, because it to me it feels like the kind of name you would put to DTP. Now, dynamic auto, I would never ever use it. Just like period, because it's to me it's like lazy configuration, just like hoping one side's going to be set correctly when you know the other side is not. So DTP and setting a dynamically negotiating whether a port becomes a trunk or not has really, to me, absolutely nothing to do with VLAN Trunking Protocol. VLAN Trunking Protocol, all it does is propagates like configured VLANs on one switch to another. It doesn't have anything to do with actually setting up trunks, negotiating whether a port becomes a trunk, any of that, even though the name kind of seems to indicate that it should. So, like I said, it's a terrible name, VLAN Trunking Protocol. Think VLAN Replication Protocol, whatever.
Yeah, it's just strictly for the
two
VLANs.
different protocols, basically.
Right.
So does this actually update the configuration
I
of
was
the switch,
just about to ask.
or is it just?
Is it like a routing table?
It updates. So you're talking about VTP right now, right?
Right.
Yes.
VTP it's not going to change the configuration of the switch, but it is going to change the vlan.dat file. So the .dat file that holds all of the information for all of the individual VLANs is.
Don't mind, maybe lose the phone. Nice.
Here, cut this.
Yes, sir.
Sounds like one call to this phone.
Okay, so the this is only going to change the vlan.dat base, since most of the configurations regarding VLANs, except like what we talked about before, like stuff on it. Yeah, it's only going to be replicating those changes to the vlan.database. There are some slight variations to that. We're actually about to talk about them now when we talk about the VTP modes. So whenever you set up your network, your switching network for VTP, each of your switches has 3 possible modes that they can be assigned to that have different roles within the network. So server mode, which is the default, client mode, and transparent mode. So VTP server, and basically these modes dictate, whether they can make changes to that database, whether they can send those changes out for other switches to make, that kind of thing. So a VTP server can make any changes to any VLANs. It can add, it can change, it can delete VLANs. Those changes occur on the server switch and then are sent to any VTP client switches in that VTP domain to propagate the same changes. Each time they go through a change, it includes the server's revision number. The revision number is incremented each time the server makes a VLAN change. If the client receives the revisions and the revision number is higher than the information they currently have, the client makes those changes. If it is the same number, it ignores the update because it assumes that, well, I've already gotten that revision number, I don't need to do anything. And if the client has a higher revision number for some reason already, it sends a message to the sender advising of that is the case. So basically, ideally, you would probably want to have 1, possibly 2 of your switches set up as VTP servers, everything else set up as a client, except for a couple of specific situations we'll talk about in a minute. Basically, so each time that you configure a change onto the VTP server, it's going to have a revision number. So it's going to start off as number 1. You make a change, the revision number is going to increment to number 2. You solidify those changes. It's going to send those changes out to all the other VTP switches on the network and include that revision number. They look at the revision number and then make a determination on whether they need to update their vlan.dat file with the VLAN changes, if the revision number matches what they need to or not. So a VTP client, to talk about this relationship, a VTP client cannot make VLAN changes directly, but relies on a server exclusively to tell them the VLAN information. So if a client is rebooted, it will not have any VLAN information until it receives a new update from the server. So clients basically sit there completely idly. You can't configure them for VLAN changes, or well, you can actually configure them for VLAN changes, but they're not going to hold it. And as soon as the server sends out another revision update, they're just going to take that information instead. So all of your changes globally for that switch network, you should be making on a server so that it can propagate those changes out to the individual clients. So the third mode, which kind of almost doesn't fit in the puzzle of this server-client relationship, is VTP transparent. A VTP transparent mode switch can make changes, but does not relay those changes to other switches. It also doesn't listen to VLAN revisions from other switches, but will still forward on any revisions. And then VLAN changes are actually stored in the running config and startup config instead of the VLAN database. So this is the one time that you'll actually see actual VLAN configurations show up in your configurations and not the vlan.dat file, is when you're in VTP transparent mode. So usually if you're configuring a switch for VTP transparent, it's probably got some kind of weird function in your network, like maybe it is the only switch on your network that's handling a particular VLAN, and you don't even really want to participating in the other stuff you've got configured through the network. That's probably the only time that you're gonna set something up for VTP transparent. This little graph on the right, though, is kind of important for understanding it. So you've got one transparent switch right here. Everything else, you've got a single server and all these clients. It is important to know, this is basically what this is showing, it is important to note that even though the transparent switch is not participating in the VTP revision changes the server is sending out, it will still forward those changes on to any other switches that are connected to it. So, it receives this VTP advertisement with revision number 135. It ignores it completely, but it does go ahead and send it out these other ports to these other client switches so that they can propagate the necessary changes.